In this video, we are going to take a look at how to use a Modbus TCP collector to collect data from a field Modbus device. As you can see in this network diagram, I have an S8VK-X power supply with an IP address of 192.168.251.160 connected to a DX100 with an IP address of 192.168.251.154. When using Modbus TCP, we need to identify which registers we need to read from the Modbus device. In this instance, the S8VK power supply has multiple holding registers that we can read using the DX100. In this example, we will focus on register number 1, which is the output voltage of the power supply, register number 2, which is the output current of the power supply, and register number 6, which is the total runtime. Please note that individual registers can be of different byte numbers. So in this case, output voltage contains 2 bytes, output current register contains 2 bytes, and total runtime register contains 4 bytes. Then we will focus on how to use the Modbus TCP component in the SpeedB Synapse software. Underneath the collector component base, we will select Modbus TCP Collector. I will drag and drop it in the panel. As soon as I do that, it opens up a window which I need to fill out. So for the name, I will type in S8VK Modbus Collector. The host is the IP address of the Modbus device. In this case, it is 192.168.251.160. We will use the default Modbus port, which is 502. I will leave the other values as default. I will click Group Read, which enables for me to read multiple variables in a single read. Then we will add the holding registers that we need to read. I will click Add. Then for the data name, I will type voltage. For the address, I will type, which is 0001. That is the address that we acquired from the data sheet or the user manual of the power supply. The type will be holding register. That in turn gives me the data type of word, double word, word unsigned or double word unsigned. In this case, I'm reading 2 bytes, which is a single word. It's an unsigned word. I will select that and I will leave the other values as default. The same way I will add other variables as well. So the second variable is going to be my current. My address is going to be 0002 and I will read that as a holding register as well. That is also 2 bytes. I will use unsigned integer. And then the last one is total runtime. That is also holding register, but that is a double word unsigned because it contains 4 bytes. And the address is 0006. After that, I will click Save. Then I can go back to configuration and I will do a test. Test is successful. And then I will start the component. To monitor the values that are coming in from the power supply, I will click this button here. And now, as you can see, I have the current, total runtime as well as the voltage in the data monitor window. Now, we can use other components to format this data. For example, current is 0.6 amps. In this case, I'm reading 60 because I'm reading an unsigned integer. And that is how we use a Modbus TCP collector in SpeedB Synapse. In this video, we will use an Ethernet IP collector component to read data that's produced by an Omron NX102 controller. For this example, I have an Omron NX102 controller with a project that's downloaded that's producing some sample data. In this case, we will focus on this GDX pressure variable. If I look at the variable attributes, it is of long real data type and it is set to be published to the network. If we go back to SpeedB UI, I will drag and drop the Ethernet IP collector component to the panel. And first, I will give it a variable name. In this case, I will name it NX102 EIP collector. Then I will enter the host address. In this case, I'm going to use the NX102 controller's IP address, which is 192.168.251.153. I am using the standard 44818 port and I have a connection timeout of 2000 milliseconds and I will collect data every 1000 milliseconds. Then I will click on the add button. Here I will select the variable name I want to read data from. So in my Sysmax Studio project, you will remember that I am using the GDX pressure as the variable name. I will type the variable name in the variable name section in SpeedB UI. Then I will have to enter a column name. The column name is the variable name that we will refer to in the panel from here on forth. In this example, I will name it as pressure. The data type will be of long real data type, the same data type that I'm using in Sysmax Studio project. The array size can be 0. From there, I will click save. Then I will go back to configuration again and I can do a test connection. My test connection was successful. From there, I can start the component. And if I click on this connector here, I can go to the data monitor section and I can look at the latest data. You will notice that the value of the pressure variable is changing. This is the value that I'm reading from the NX102 controller using the Ethernet IP collector component. In this video, we will take a look at how to collect data from an Omron NX102 controller using the FINS protocol. As you can see here, I have a Sysmax Studio project that's generating random values to GDX pressure variable as well as GDX ACT TRQ variable. Before we download the program to the NX102 controller, we have to ensure that the FINS setup is configured. To get to the FINS setup, go to Controller Setup and Built-in Ethernet IP port settings and click on the FINS button. As you can see in the FINS settings, FINS UDP is enabled and FINS will be communicated through port number 9600 and the FINS node ID is automatically generated from the IP address of the controller. In this example, the IP address of the controller is 192.168.251.153. Therefore, the FINS node address is 153. It's important to note that the NX102 controller can communicate FINS protocol through port number 2. Next area we need to focus on is the memory settings of the NX102 controller. FINS protocol is an address-based protocol, which means it needs to have physical memory addresses to collect data from. In this example, we have the GDX pressure variable and the GDX actual torque variable declared in the global variables list, but those have not been assigned to a physical memory area yet. Underneath the memory settings, we can enable the DM memory area and then go to the global variables list, find the GDX pressure variable and GDX ACT torque variable. Notice that both variables are of the long real data type. And then in the AT section or the column, type %sign D0 to indicate that GDX pressure variable will be assigned to D0 memory location, and that will take up 8 words as it is of long real data type. Then assign %D8 to the GDX actual torque variable underneath the AT column. Then download the project to the NX102 controller. Now let's open the SpeedB user interface. In the component base underneath the collector section, drag and drop the PLC collector into the panel. Then let's give it a name. In this instance, I am going to name it NX102 FINS collector. Select Omron as the manufacturer and Sysmac NJ-NX series as the machine type. Then type in the host IP address, in this case the IP address of the NX102 controller, which is 192.168.251.153. Type in 9600 as the port, which is the FINS port number that is set up in the Sysmac Studio project as well as the NX102 controller. Then let's select the Keep Connect option. After that, we will add variables in the variables field. Click Add and underneath data name, enter pressure, address D0, data type as double, click Add again, then data name, give it as torque, address of D8, data type of double. Click Save, and then I will go back to the configuration and click Test. My test connection was successful. I will click Save and I will start the component. Since I am online with the NX102 controller, I will enable the random variable generation. Then I will click on the output port of the PLC collector component, and that will open up my data monitor, which I can monitor the live value change of the PLC collector component. As you can see here, I stopped the random value generation, and in Sysmac Studio, I do have the last value sent to the SpeedB UI, and they do match with the PLC collector as well.